my knowledge in breeding for resistance, but your background in breeding as well, I think you should be the appropriate one. Not long ago, I was in a lecture, was told that resistance mechanisms are different ways. One of them is hypersensitive resistance, and that is the pathogen will get in there, but the host or the plant will induce a mechanism to kill the immediate cells that surrounds the pathogen, and therefore further infection cannot occur. And in such instances, my understanding is that you will see symptoms on the plant, but it will not spread. But Prof. Lamte was also alluding that if there are symptoms, then it cannot be called resistance. How do you respond or reconcile that? Then, again, from your background in genetics, you should also attempt this. Breaking down of resistance. I understand that there's nothing like breaking down of resistance. It is lock and key affair or issue. Once the key fits on the door, it's able to open. Once it doesn't fit, it's not opened. And so you develop resistance as a key to lock the door, but the pathogen is also so smart that it changes its genetic makeup. And so when it changes its genetic makeup, it's not the original one. So you can't fault that one that is not effective. But because a new one is there, you need to develop a new mechanism to manage it. And so let's clarify our thoughts. Otherwise, we don't say resistance has broken down, we say it that way. So how do you respond to that? Thank you.
If you get the mic, you try to be very brief because you are far behind time. And I think the interaction will continue after here.
Thank you very much, Prof. Francis. The new virus strain we identified. Maybe the economic advantage will be that now that we are breeding cassava-resistant varieties, we take that one into account. And going forward, we will know that we come out with varieties that are resistant, and then they will be high yielding. So when you sell them, you get more money. Or if even for industrial use, you can get more quantities to use. But in terms of making money out of the virus, nobody will buy the virus. And the sequences are not sold. They are for academic use. So it's there for anybody who is interested to maybe design primers to identify them to do so. It's not sold. I can just go onto the internet, NCBI, download some sequences and make primers and use it for academic work I want to do. You don't pay any money. But the advantage is that breeders use it to get resistant varieties that can indirectly make income. Concerning the yellow Brazilian lines, I cannot say for sure, or what I would say is that when they brought it, the information they told us is that it's not GMO. And we don't have capacity now to test whether it is GMO or not. So we just go by their word and then certification that came with it. So I will take it that what they are saying that is not GMO is true. If they are lying, that one, I cannot confirm that. Then, Dr. Wafi, resistance mechanism. Yes, there are several resistance mechanisms. In some cases, even the pathogen cannot enter the host. In some cases, it's able to enter the host. In some cases, it's able to enter and move on, and then it will die. So, if it's able to enter the host and is able to express some symptoms, and the host system is able to suppress it, then you can declare it as being resistant because it shows some symptoms, but it died off, and it didn't have any effect on yield. But in some cases, it doesn't even attack the host, like it doesn't even enter the host. It will come into contact with the host, but it's not able to enter. There are no symptoms, you don't see anything. Then you can say that it's showing some level of resistance. But in all this, you confirm with tests. You can't just use by mouth or by eye and say that like maybe one off activity, then you come out and say it's resistant. That one is not acceptable. That's why it's experiment, it should be repeatable. And then once that is done, then you can conclusively say that actually this is what is happening. Then the second question, breakdown of resistance. Yes, this term is used. You say that resistance has broken down. What you are saying, you are right in the way because the virus, especially for pathogens, they are always like mutating. Once they encounter a challenge in their host, they want to find a means to survive. So they also change their constitution, their genetic makeup to survive. And in that doing, they will outwit the host mechanism of the host. So in that case, you will say that the resistance has broken down. It's a terminology that is used to describe a situation. It's not that the original mechanisms that's resistant to that virus in the host is gone. It's there. But the pathogen has maneuvered, I would say maneuvered, the resistant mechanisms, and is therefore able to cause infection, new infections in the host. So that's how it normally happens. Thank you.
Yes, Prof. Joe, please, I didn't do the jet plasma collection. And this was a project under the Next Gen, which is being headed by Dr. Ruth Prempe. And I went in just to assess for the disease incidence and severity, so I did not do the collection. And for the resistance, my boss has really explained it, so I think that's it. Thank you.
I think we've come to the end of this session. And
when they are given the opportunity to ask questions, I think they should also, because with the public, most of us also have questions to ask. But then when you ask so many questions and so on and so forth, we don't get the opportunity to also ask the questions that we have. So please, in the next session, let's take that into consideration. Okay. Thank you.
Okay. But this is happening because we are already far behind time. That's why we even said 1 1 1. Thank you. So please, let's applaud the presenters as we come to the end of the session. And we also applaud ourselves for sitting through and participating. Let's applaud ourselves.
We are breaking for coffee now. As we had it yesterday, the director have to...
Alright, TV Beyond the Research, and this is the maiden edition of Women of Science. I have here a noble woman who is going to be our guest for this maiden edition. Here in Ghana, mention GMO and her name follows. Mention biotechnology and then you see her name again. And she is the Deputy Director of CSIR Crops Research Institute, and she has a tall list of many achievements. I don't want to go on with many other things that are related to her, and that's the reason why she is here, to tell us more.
Next presenters.
Her name is Professor
Upload your
Marian
information
Dorcas
on the
Queen.
computer.
Prof, you're welcome.
Thank you very much.
Welcome again to Women of Science, and this program seeks to celebrate women who are making waves or making strides in science, and is to inspire lots of young women or other women who are trying to give up in their journey of science. So welcome once again.
Thank you very much.
So I have mentioned your name, but I want to know, who is Professor Marian Dorcas Queen?
I would say Marian Dorcas Queen is a research scientist who has a passion for science. I've been working in the field of tissue culture since my BSc in 1988, 89. I graduated in 91 from the University of Ghana, Legon.
Wow.
With the botany department. I was mentored by Dr. Elizabeth Champon, and I owe her a lot in my expertise in tissue culture. She's the first person who ever taught me tissue culture, and I really appreciate. So in a nutshell, for my beginning from BSc, that is what I would say.
Okay, you mentioned the Department of Botany, and that's Legon, the premier university. I realized that your BSc was in botany, MSc botany, PhD botany, and in chemistry, one would say this is aliphatic, a straight chain. What is so fascinating about you and plants? You know botany is the study of plants. What is it about you and plants?
Growing up, I knew I liked fidgeting with things, and I would like to do research. My father, the other thing would be pharmacy. And that